And could you all just give a quick introduction to the audience? Sonita, we'll start with you.
Okay, yeah. Hi, I'm Sonita Lontoh. I'm the Global Head of Marketing at HP. Actually, I've transitioned a little bit from the energy industry to a new, I guess, IoT innovation in manufacturing. So HP actually has a new business, 3D printing and digital manufacturing. So I've been there for about 10 months, but my heritage is really from the energy industry. I started with Pacific Gas and Electric Company some time ago, and while I was there, truly focusing on their renewable strategy and smart grid, and then I moved to a startup that was offering IoT platform against serving the energy industry, and after that I went to Siemens, actually in their digital grid business unit, again trying to help utilities in their digital transformation. So really look forward to the conversation here, because this industry is actually near and dear to my heart, because it's really the kind of that interesting intersection of new technology coupled with new business models and also policy.
Great, thank you. My name is Adnan Mansour. I'm with GE Power, more specifically GE Power Digital. Been with GE for, practically speaking, my entire career, about the last 20 years. Started off in engineering in the water business. GE was in the water space for about 15 years. Recently disposed of the business to Suez, but spent 14 years in the water business, primarily in engineering, but transitioned to, from a product development standpoint, transitioned to digital about 7 years ago as the notion of IoT and connected assets came into play from a GE perspective at least, and helped establish a digital capability and platform for the water business. About 3.5 years ago, relocated to San Francisco, to the Bay Area, to work in the digital IoT space for GE Power, and more specifically GE Power Digital, leading our product and strategy organization. So happy to be here and happy to talk about the intersection of power and water with everybody today.
Thanks. So like Chris mentioned, this conversation will focus around data. And so I wanted to first ask what the digitalization landscape really looks like for water and energy utilities, specifically around deployment of IoT devices.
I can start. From a water perspective, I'll flip back and forth between water and energy, water and power generation, that is specifically to say. From a water perspective, getting assets connected in the water industry, I heard somebody mention in the previous session that these plants and capabilities have matured over the last 100+ years, and that's obviously the case. And just the way that these systems, utilities are managed and operated is by folks who understand and know what they're doing. Getting systems connected, there's DCS systems, SCADA systems that run and operate the plants. There's the control room. But really, in terms of connected devices that look at key KPIs or inform on key KPIs that are relevant to the plant, are much more limited than the actual operating system technology that exists. And from my perspective, at least during my tenure in the water space, from a public utility standpoint, probably 10 to 15% in North America, less so globally. And from an industrial perspective, depends on the industry. In energy and oil and gas, for example, connectivity is about 20% in the utilities, even less so in some cases. From a pharmaceutical water standpoint, from bottling plants, et cetera, much higher than that. So it varies from an industry perspective, but it's still in the single digits to teens, depending on where you are globally, and the maturity of or the progressive nature of the customer specifically. From an energy standpoint, I would argue it's the same, if not less. From a power generation perspective, GE runs or has deployed about 40% of the globe's total gigawatt capacity, and so we've got a pretty good handle on the assets that are out in the market that are generating electricity today. And from an operational technology, again, everything is obviously connected, but from an IoT perspective, as we define it, from connected systems and devices, it's significantly less, and I would argue in the single digits from a percent penetration standpoint.
So I want to take a little bit of a different take on that, using like my previous utility experience and also working with different utilities, with Siemens and with the startup. The way I want to view kind of like digitalization or the need for digitalization is from the perspective of the major trends going on around the world that I think are necessitating digitalization for the utilities, namely, decentralization of energy, With that comes the democratization of energy and then decarbonization of energy. As we all know, energy is becoming more distributed, closer to where the demand is. With that, comes democratization, which means like consumers who in the past would only be would only be consuming energy, now become prosumers. They can also produce energy. And then last but not least, of course, there is this drive by different governments with mandates and all that to reduce greenhouse gas emissions, and utilities have various RPS standards that they have to meet. So I think like these trends kind of create the challenges, but also opportunities for utilities to embrace digitalization. And kind of like, it's funny, I was in smart grid, I started in smart grid maybe 15 years ago, and there is always a question, like, what do you mean by smart grid? Because for some people, the transmission side has been smart for a long time. It's really the distribution side. But when you really think about it, it's really this layering of intelligence and connectivity, two-way communications across the whole value chain to kind of enable a more balanced system. Because traditionally, if you don't have that, the energy has been created at a centralized plant, pushed one way to where the demand is without much visibility and control, resulting in a lot of inefficiencies and waste. But then with the advent of this energy IoT or connectivity, two-way communications, intelligence, there will be a more balanced system between supply and demand. And so in terms of penetration, I think I agree with Adnan. I think there is no kind of one size fits all because every utility is different. They have different regulatory environment, different territory, different kind of business drivers as why they might want to do something. Some want to do it to improve operational efficiencies. Others, they have a lot of renewables, distributed energy in their area, and they have to deal with that. Still others actually would like to offer new business models, more new value-added services for their consumers. So there's really no one size fits all. And so in terms of just penetration, I would say in the last 10 to 15 years, I think some of the maybe more progressive utilities are doing it in a big way. And some of them are actually in Europe, and it's because of the renewables push by the government. And others, they are kind of like having pilot projects, but maybe not kind of deploying it in a big way.
And how does, once the IoT is deployed, how does that really help utilities optimize asset management and asset lifecycle?
Okay, well.
You want to start?
Yeah, I'll start and then.
Sure.
So again, the way I kind of think the benefits of IoT is really in three big buckets. One is to improve operational efficiencies, and I think that's where this asset management falls under. And so with the advent of smart sensors and connectivity, there's a large amount of data that are created from the devices and assets out in the field that utilities have access to. But of course, we all know that just having access is not enough. In order to take advantage of it, you have to be able to actually visualize it and also analyze it so that it gives you not only insights, but most importantly, action, And I think this is like the part where utilities can leverage all this data that they have to analyze and provide some advanced applications. I think there's a lot of talk about predictive maintenance in the industry, the ability to continuously monitor the status and health of the assets and actually maintain the asset, provide targeted maintenance before the equipment fails, and which of course will be able to allow the utilities to have a more optimized system.
Yeah, I would agree, Sonita. It's about getting the assets connected and having data streaming. I mean, there's a ton of data that's being collected today that's actually not being used. Again, depending on who you're talking to, you could argue that, again, it's less than 5% of the data that's actually being collected is actually being used by generators or whomever owns that data to allow them to really analyze and infer from that data what is happening to those assets. And it's not just about the assets, it's about the entire system, right? So you think about it from an asset perspective, you've got to have the right asset model, you've got to have the right data that's coming in off those assets tied to that asset model. And then it comes to the analytics, the predictive analytics, right? So yes, you've got the state status and health, so you can see trends and you can alert and alarm and observe trajectories to basically make determinations about what's happening with that asset. But then there's an notion of predictive analytics and the concept of a digital twin, as it were. And everybody's got different definitions of digital twin, so we won't litigate it or define it here, but if you want to, we can. But independently, it's looking at predictive analytics associated with those assets and trying to understand or basically determine or predict when an issue is going to arise so that you can address that issue before it actually leads to a forced outage or an unplanned event. And then taking it one step further, you've got these models in place. You've got these analytics in place, and the more data you have, by the way, obviously, and the more conditions you have, or the operational parameters that you have, the more reliable these analytics become. There's a lot of advanced pattern recognition technologies that are out there today. We do them. There's a lot of other firms that do them as well. And the rate of false positives associated with those is pretty significant. It's pretty high. So bringing into that physics-based models, bringing into that operational impact factors, bringing into that the overall data intelligence, the domain intelligence that interprets this data helps you refine those models and add parameters that are going to help you have lower false positives, layering analytics, again, lower false positives and better results in terms of the prediction of potential failures or issues. Take it one step further and you start thinking about, all right, well, I've got the predictive analytics, I've got the state status and health, what else can I do? Well, I can optimize I can optimize on reliability-centered maintenance, value-centered maintenance even, and start thinking about developing strategies to do what you need to do when you need to do it. Everybody's stressed and in terms of cost and managing cost. So do what you need to do as opposed to do what the owner's manual tells you to do, because you've got intelligence that enables you to be smarter about managing assets. A lot of folks, I'm sure, are aware that when you open up an asset to do preventive maintenance, when you put it back together, it's never exactly the same. Anybody who's pulled anything apart at home knows this, right? So minimizing the amount of time that you have to spend doing preventive maintenance and only doing maintenance when you need to becomes critical. So that's on the asset piece. And then think about it from the overall operational piece, right? These assets are all interconnected, and there's upstream and downstream effects associated with each asset. And so understanding operational KPIs and how those manifest in terms of what's happening with assets upstream or downstream of where you're identifying challenges becomes important as well. And so building technologies to optimize on operational efficiencies on, for example, from a generation standpoint for capacity, for example, optimizing on heat rate, for example, optimizing on flexibility associated with starting to manage fuel costs and those sorts of things. So there's that aspect of things as well. So it really makes an enormous difference when you have data, understand the data, are able to understand the data, then able to understand what kind of models and analytics you need to build with that data to optimize performance, reduce costs, reduce outages, and certainly improve and ensure reliability, and availability for that matter. So it's all interrelated and it's all interconnected and relevant. And what I described for the power piece, the generation piece, is completely relevant and identical parallel in the water space as well.
Adnan, you mentioned all the data that's being collected and how little of it's actually being used. So how is digitalization helping to ensure better quality of data? And how does having better quality data actually ensure a better experience for customers? Sure.
So, in terms of getting assets connected, now you're collecting data associated with those assets. There's tools that you can build that in the platform that you're using. We've built our own that will scour that data and ensure the quality of the data, one. But secondarily, having visibility of data helps you understand when you're collecting data that's actually not accurate. Again, if you think back to legacy systems where data is analog or it's manually collected, there's enormous opportunity for error. So you're eliminating that factor. In terms of data that's streaming, again, you've got to ensure the quality of that data and that there isn't erroneous data being collected. So building algorithms that allow to assess for quality in that data. So one, collecting the data reliably and continuously improves visibility of that data, improves intelligence that you can glean from that data, and secondarily building algorithms that scrub that data, if you will, for quality also ensures improvement in terms of how that data can be used. And so once you've got clean, if you will, excuse the expression, clean data, clean and high quality data, the algorithms that you build, the models that you build from a predictive analytics standpoint obviously become more reliable. And then again, as you layer those analytics, those various types of models, again, you're getting better information faster and more effectively and more reliably. So it really comes down to eliminating human error, eliminating transcription error, eliminating getting more data. Again, when issues arise, those issues arise when you're not collecting data. They always happen to, and failures always happen to occur in the in-between periods. And so when you've got continuous data streaming, you're getting intelligence on why data associated with the event as opposed to data around the event. So again, you're improving reliability of the analytics that you're building in that context as well. Yeah, I'll stop there, but lots of opportunity to discuss.
Yeah, sure. So maybe building up on that, maybe just share kind of like some real life examples of like how digitalization, energy IoT providing, enabling the utilities to provide superior customer experience, to the end consumers, because you have all this data and it's in a much more granular and actually insightful level. You can actually you can start to be able to offer value-added services to your customers. So let's say, for example, you better understand the end consumer's kind of energy usage pattern. Then you can recommend a pricing plan, including time of use plan that might best fit the customer's needs without actually reducing the customer's comfort and convenience. And then the other kind of like benefits, I would say, from just having this connectivity and data is being able to actually respond to outages, faster and more accurately, because in places, I would say, in the United States and even the world, where there is no connectivity and this data is not available, usually when an outage happens, the customer has to call the utility, and then even when they send a crew in, the crew doesn't usually know kind of exactly where in the systems, that is causing the outage. But with the advent of the data and the connectivity, it usually helps the crew to actually pinpoint where in the system is actually causing the outage, and they can fix it faster. And I guess right before I came here, I read statistics that EPRI said outages in the U.S. Cost the U.S. economy about 180 to 200 billion per year in lost productivity. So just a reduction of 10% of that, as you can imagine, already save a lot for both for the customer but also for productivity loss.
And Commissioner Sandoval touched on this a little bit earlier today, but what are some opportunities for syncing water and energy data or power data? So,
from the standpoint of water and energy, we talk about the water energy nexus. That's what this is about. Just some simple statistics that folks, just to keep it really simple, is that you need energy to make water, full stop, right? Power generation is required to pull water out of the ground or from whatever the source is, to pump it to wherever it's being treated, to pump it in distribution networks, to processing it, to treating it type thing. So significant energy is required there. And likewise, you can't, from a conventional standpoint, again, solar and wind excluded, nuclear, coal, and gas power, certainly still the vast majority of generation in the United States and globally is by those means, require water. And another simple statistic is that about 40% in the United States, just under 40% of all water consumption is used in the energy industry. And so the two are inextricably linked. And so if you think about cooling towers, boilers for steam generation, et cetera, in water plant, in generation plants, you can't generate power without steam. You can't generate power without cooling capability. So making sure that the data associated with the ancillary equipment in the power plant that is allowing you to generate electricity and vice versa, making sure that power generation is available to treat that water becomes essential and frankly inextricably linked. And so putting those two together ensures that you minimize and mitigate failure. One of the use case that I worked on when I was in the water business actually was our power business had some aeroderivative engines at a C&I facility, a university specifically, that were producing power for the power plant. And we were treating the water utilities, independent of our power business siblings. The aeroderivatives had a forced outage. Nobody understood why. It literally took 3 days for them to deconvolute the data to get to the fact that it was a cooling tower turnaround that led to this failure. Nope, the physical plant, the utilities folks and the physical plant weren't talking to one another in terms of water versus energy. And so we connected the two sets of assets, the cooling assets, if you will, and the power generation assets to prevent any future failures from happening, such that when somebody was treating or working on the water utilities, was also connected to the folks who were managing the generation assets. And so just in simple terms, without one, you can't have the other, and vice versa. And putting them together ensures reliability, ensures availability, and ensures optimal efficiencies as well in general terms.
And Sonita, you had mentioned decentralization and the democratization of energy. And so I know you worked on a project at Siemens, I think it was a microgrid project. Can you talk a little bit about that specific project and how it kind of shows that digitalization and decentralization can lead to more sustainability?
Yeah, sure. Yeah, and actually I want to talk about kind of like two microgrid projects that are kind of like illuminating different kinds of, I guess, benefits. So the first one is with Blue Lake Rancheria. It's actually a Native American reservation up in Humboldt County here in Northern California. It's a pretty remote community, thriving, but they also have kind of this emergency shelter for the Red Cross. So they really kind of like need reliable and resilient power there. And so for this particular project, for me, it's really kind of like an example of how a community and then the utility, actually PG&E, and the government, and then a national lab, and also several technology providers such as Siemens and Tesla as well, are actually working together to develop a low carbon microgrid that is, with the aim of providing not only sustainable and resilient power for the community, but also providing local green jobs for the community. In terms of like the microgrid itself, it is a combination of photovoltaic, solar, and battery storage solutions and biomass. And the microgrid is actually can be connected to the grid, but also can be islanded in emergency situations and can provide reliable power to the community for 7 days without interruption. There's some benefits that they have documented about this project, including energy cost reduction about 25% per year. And then a reduction is greenhouse gas emissions as well, because the community is not that big, so about 200 metric tons of CO2. And of course, the creation of these clean energy jobs for the community. And then the other microgrid project that I actually kind of want to share as well, because even though it's microgrid, but slightly different, it's a project with a college up in Ontario, Canada. So it's a public college with about 20,000 students, 20,000 full-time and 37,000 part-time students. And what is interesting is, this college has a really kind of bold vision to be zero carbon footprint by 2040, but it's also really trying to integrate sustainability into their curriculum. So I was actually staying and listening to Eric Dresselhaus saying that, because you cannot educate the parents, you go educate the kids. And I think this college is kind of like trying to do that because they're integrating sustainability into all of their undergraduate curriculum and also have a sustainability program, a graduate program. But what is interesting, it is also acting as a living lab, by integrating a lot of the leading edge technology. It has a microgrid on campus. It's a combination of, again, solar, battery storage, and actually cogeneration, and is employing sophisticated microgrid controllers in order to be able to balance the supply and demand for the campus. And it is letting the students, actually have access to this technology, providing them with hands-on kind of learning experience. So for me, while the two projects focus on providing resilient, reliable energy for the community that they're in, it's kind of interesting that one is creating clean power jobs, and then the other one is trying to educate, the next generation students for a more sustainable future.
We just have a few minutes left, but so for my last question, what role do you see AI playing in the future?
AI. Okay, so I'm going to try this. I think it's very emerging, but one application I can see is using AI to just manage kind of the speed, scale, and complexity of trying to manage the grid, especially with the emergence of all these renewables and distributed energy. As we all know, the renewables and distributed energy are unpredictable and intermittent, because the sun doesn't always shine and the wind doesn't always blow, which is causing a lot of problems with regard to trying to balance the supply and the demand. So on the supply side, when you actually need the energy and it's not blowing, you're then using all this backup power that are usually dirty diesel and or coal-fired power plant. And then on the demand side, when there's too much energy being produced, then you need to use expensive energy storage to store the energy to be able to release it later. And at some point, I think this will be too complex for human. And perhaps I think the application of AI to actually manage this complex system because of the renewables would be good.
Yeah, I would just echo that. Those same example that I was going to use, from our perspective, from my perspective at least, think about it from the generation standpoint, the transmission, distribution, et cetera. Operational technologies have been in place for generations, right? And certainly from an optimization standpoint, talked a little bit about asset optimization and systems optimization to ensure reliability and availability and obviously operational efficiencies, but then connecting all of these three pieces, if you will, the generation, transmission, distribution, and really optimizing on the network. Back to Sonita's point around the distributed energy resources coming onto the grid at a really rapid pace, and the lack of reliability of those, right? There's in terms of knowing when the wind is going to blow, when the sun is going to shine, and manage the grid associated with that. AI is going to play a significant role from the standpoint of the network and optimizing on that network and ensuring that network is, for all intents and purposes, stable and reliable. So the reliable grid becomes a significant use case and at a place where AI, I believe, is going to make an extraordinary difference in our ability to stabilize the grid with the onset of DERs. Yeah.
Great. Well, thank you so much to both of you for being here today and sharing your perspectives. And thank you.
Thanks for having us. Thank you. Thank you.